Hi, everyone. We sincerely appreciate you joining us for what we hope will be a useful and interesting discussion. The topic of today's talk is explaining explainable AI. And if you're tuning in, you're probably aware that explainable AI and interpretable machine learning and fairness in machine learning are very hot topics these days. And we're super lucky to have someone who works right in the middle of the real rubber hits the road practice of all this stuff on the line today. And that's Tom Aliff from Equifax, where he's a Senior Vice President for Analytics Solutions Consulting. And I'm Patrick Hall, and I'm a Director of Data Science Products at H2O, and we also do some work in this space. So very briefly, I'll turn it over to Tom if he'd like to add any other introductory comments or things he thinks may be germane to his experience on this topic. I'll let him go ahead.
Yeah, thank you. I appreciate it. Good morning, afternoon to all of you that are out there. I've been involved, as they said, with the actual practice of taking various elements from the data science world and applying them most specifically, to credit scoring. As many of you may know, it's a highly regulatory environment that requires a lot of clear, explanation behind what's going on underlying that, and I think it's created a very clear business need for the types of things we need, from leveraging AI to moving that towards explainable AI. And my background comes from I was a hands-on data scientist myself in this space, and now what I do is I lead the consulting practice within our organization, spanning multiple verticals, including financial services, telecommunications, mortgage, auto, et cetera. So looking forward to the discussion today. Thank you.
Cool. Thank you so much. All right. So with that, I think I'll just jump right in to our first question. I'm going to stop sharing the screen for the moment, and we'll be sharing some links and other additional resources with the audience through the chat boxes and again after the webinar is over. So stay tuned there. But for the moment, I'm going to stop the screen share. Okay, so Tom, our first question is, what is explainable AI? And I'll let you get started, and of course, I have some comments to make on that.
So I guess, taking it back to breaking it apart into its pieces, we would talk about explainable, and then we'd talk about AI. And so from our perspective, in the way that we've been leveraging, it starts off with artificial intelligence, and oftentimes that can be leveraged as an algorithm, one that's oftentimes machine built, in the sense that there's a lot of involvement with the machine to generate the algorithm that's needed. And sometimes those algorithms can be created and implemented in a static way. Sometimes those are implemented and created in a more dynamic fashion that update. But the idea then combining the artificial intelligence piece with explainable is that oftentimes those models become very complex, and a basic form of that would be a neural network, where it's very complex in terms of trying to understand what are the key drivers behind that. And in our space, specifically for credit scoring, it's quite important to be able to explain that. If you're declined for credit, for example, there's ways and mechanisms to go out and look to create an update, and work on improving credit profiles for that. So specifically, explainable AI allows the users and those that are creating it an understanding of what's going on behind what previously could have been viewed as a black box.
Okay, cool. That makes a lot of sense to me. I'm going to add just a little bit of commentary. So from what I'm aware of, the actual phrase explainable AI came from DARPA, and I'm sharing this link on the screen now. So I think this may be an interesting resource for those on the call to look into later. I think they certainly have different applications in mind than we do at H2O and probably in the financial services. But DARPA being the people that brought us the internet, it might be interesting to see what they have to say with it. And like I said, as far as I know, this is kind of where the term came from, or the phrase came from. I will also point people towards this kind of white paper. It is an academic paper, but it's fairly digestible, and it gives some good definitions and goals for interpretability in general in the space of machine learning. And again, we'll make these links available to everyone after the call. To be very clear, what I think we mean by explainable machine learning, and I'd be interested, and I really want Tom's feedback on this actually, is this idea that we have our kind of known machine learning workflow, and when we used to just train models and score data, right? Or maybe Tom never did that. I don't think that's a good idea personally. But now what we're saying is we can explain what the model did. And so Tom, I'll give it back to you really quickly. Do you see explanations as something that happened after a model is trained, or is it kind of a broader idea to you?
I would say that it always had to be iterative in nature in terms of like a legacy type of approach, is that you'd have to have understanding of any regulatory concern, business concern, and then also trying to maximize your predictiveness. And sometimes those are competing objectives, because there are things that could have been more predictive, but it wouldn't necessarily pass from a logical business standpoint. And those are very critical and important things to consider.
Okay. No, I think that's a great point. That maybe I need to update my little slide here with an arrow going back, that this is an iterative process. I guess for the people on the phone, the main point I'm trying to make here is I feel that when people talk about explainable AI, they're often, but not always, talking about something that happens after the model is trained that's done to explain the model. And I think the last thing I'll show on this question, and this is the question where I have the most things to show, sorry, is a very interesting criticism of this idea of explaining complex machine learning models. And Professor Rudin is just an incredibly bright mind and important person in the field of machine learning, and particularly in interpretable machine learning. And I think she makes a lot of really good points here, and probably conscientious practitioners should be aware of this. I think her stance is a little bit too extreme personally. I think it's fine to mix interpretable models or interpretable variants of machine learning models with post hoc explanations, but just to get the full width of discussion, I think it is fair to say that there is actually some criticism of this type of approach. Okay, so our second question is, and Tom already hit on this, what are the business drivers for interpretability of models in your industry? Is it driven by regulation? Are customers asking for insight into automated decisions? Or is interpretability needed mainly for internal purposes? So I'll turn it over to you, Tom.
Sure. Well, I think to take it even a step back from that in terms of what's being asked for, the value proposition behind AI is quite stunning in general. Specifically from the standpoint that it allows us to incorporate more data, more information, more attributes, features, et cetera, and hopefully trying to find additional signals that we may not have been able to detect with other types of methodologies. And really, to drive towards that improvement of whatever predictive performance that we're trying to assess. And within the space that we operate in, specifically if we think about credit scoring, it's leveraged for all financial services decisions. When you're opening a mobile phone, et cetera. There's a lot of information that goes into that. And in terms of these credit scoring systems, there are key regulatory requirements as well as business requirements for these models to be explainable. And the governing bodies that we operate with are under their a few acronyms: the FCRA, which is the Fair Credit Reporting Act, the ECOA, the Equal Credit Opportunity Act, and then a few other areas that are niche specific, according to mortgages, et cetera. But in addition to that, the Equifax business requirements, we work with our customers, and they always want to have a logical explanation.
Tom, for a moment on the phone. Are you there?
I am here. Yes.
Okay. Hello? So I'm going to switch over.
Can you hear me now?
Yes, Tom, we can hear you.
Okay, I'm not sure what happened. I heard you the whole time, and I'm not sure where I fell off.
I believe Patrick dropped, so let's give him a moment to try to rejoin.
Okay.
Apologies for the delay.
Okay, I'm back. I'm sorry about that, you guys. Can you hear me?
No worries. Yeah,
no
I can hear you. Can you hear me fine?
Yeah. Yes, yeah. I have phone issues in my office. It's really, really unfortunate. Okay, so I'm sure that Tom gave a wonderful answer to that question, and I did hear most of it. I'm going to chime in with my own sort of just a little bit of commentary, and we'll try to keep things moving. And please let me know if my comments are off topic based on the fact that I dropped for about 30 seconds. So one thing I want to bring up is GDPR, and that is of course a fairly complex new thing out in the world, in the market, that people are just trying to wrap their heads around. And so really I'd just like to show this piece of work by a friend of mine who's a legal expert actually on explainable AI, and point to this as a way to get some of your questions about how GDPR might affect machine learning answered. And I guess I'll turn it back over to Tom. I know you brought up some of the U.S. regulations that impact your work, but what about GDPR? Is that something that you guys have to be concerned about at Equifax, or in real life you're not really seeing that yet?
I've not personally come across GDPR. That does not necessarily mean that it's not impacting us in other areas. I've not personally come across that component.
Sure. And I'd have to say I feel the same way. I hear a lot of anxiety about it, but I don't yet see it impacting U.S. businesses on the ground. Okay, so our next question is, do you believe there is a trade-off between the accuracy of machine learning models and the interpretability of machine learning models? This is something that's spoken and written about frequently, but have you ever seen this trade-off in practice? So Tom, have you ever seen this trade-off of accuracy and interpretability in practice, or is it something that if you try very hard, you can actually kind of get around?
Well, I think those are two, I guess on the surface, competing objectives. And I believe in some cases that it's that you can identify where that could exist, where interpretability and predictiveness are really aligned. But in some cases it's not. And I think what machine learning allows us to do is to really fully assess that. And I think so in some cases where and I guess where I have found personally the machine learning type of models to really purely outperform more traditional based models is where you require a lot of nuanced segmentation, where you're going off into scoring very rare events, and those are the kind of places where that type of methodology is more important. But I think it's equally important to understand and to test those types of things. So I think that in some cases what we found is that when you constrain models in such a way like we have with some of the methodology we leverage called a patented explainable AI that we have called neural decision, what it does is it can actually create a more stable model over time due to the constrained effort that it has. Because some criticisms of machine learning is that it's overfit to the very specific instance that you have, and you may not necessarily be able to apply it long term. And those types of things are also important to address.
Okay, so I think I just agree with you 100%, and I kind of want to reinforce it to the audience. Like, I think a really exciting new direction in machine learning is this idea of constrained or Bayesian versions of classic machine learning models. Tom is talking about a constrained type of neural network that Equifax has been working on and patented and put out into the market. There are other types of constrained machine learning models, and I think this is a really exciting direction for research and for practice. And just to kind of give my 2 cents on this, I'm actually, and even though I'm like on the record saying there is a trade-off in writing in public, with a little bit more time to think about things, and I guess by a little bit more time I mean years, I'm now skeptical actually that there is a real trade-off between accuracy and interpretability. And let me give a caveat. In low signal to noise ratio problems, and typically problems about human behavior are those kinds of low signal to noise ratio problems. So in my line of work, kind of traditional data mining, I am becoming very doubtful and dubious of a trade-off between accuracy and interpretability. And maybe on static test data sets, kind of internal static test data sets, we might see incremental improvements from very complex models. But my hunch is that when these are deployed on new, real, live streaming data, that incremental accuracy increase goes away, and maybe they actually even perform worse. And so yes, I agree with Tom that I think there's a lot of value in working with these kind of constrained versions of machine learning models, because 1, they're more interpretable, and 2, they don't overfit. So great. And like I said, I just feel I just agree with you so much there. So if there's anything else you'd like to say, feel free. I'm going to show one more link before we move on to the next question. Give me one moment. So again, I'm going to highlight Professor Rudin's work here. She's done incredible amounts of work in a very short amount of time and constrained kind of rule-based machine learning models that I'm personally very, very interested in. Okay, and with that, let's move on to the next question. So do you see a connection between transparency of machine learning processes and decreased financial or operational risk? So I guess this is kind of a softball question for Tom, but maybe for people that aren't working in financial services, this isn't so obvious. But so Tom, do you see a connection between transparency of machine learning processes and decreased financial or operational risk?
I think there's absolutely a connection between those two, and specifically when we think about the regulatory and business constraints, and even as a consumer myself, if I'm applying for some type of credit instrument and I don't get the best terms or what I believe my credit profile should exist, it's helpful for me to know that so I can take action on that. So, for example, a great example of this would be if I have delinquency on an account that I have and then I apply for new credit, the reason from that model needs to be very clear and explainable in the sense that it can help the consumer, take action to improve. So if I have delinquency on a revolving or some type of bank card account, then I can go back and I can take efforts to to try to change that behavior that I've exhibited. So we definitely see that in this industry and space, and specifically, even if it's not incorporated in that way, even from a competitive standpoint, there's so many areas where consumers can go seek out different types of credit. So it's not just a regulatory risk, a business risk, but even a competitive type of risk. You have to have the best, be able to provide the most accurate and predictive view in the space. So absolutely. You still with me?
We might have lost Patrick again. Please stand by.
Okay, I'm back again. I'm going to chime in and say that, and assuming people can hear me now, that I really see a win-win-win with interpretable machine learning. So not just a win-win, a win-win-win. And it's because that with better models, right? So machine learning as opposed to traditional linear models, we should see better business outcomes. So that's the first win. Interpretable machine learning, as we've discussed, I would say does decrease operational and model risk. So that's the second win. And the third win is just that it's the right thing to do. So making models more transparent, less biased, and more trustworthy is one, going to keep you out of the media, right? If you don't care about doing the right thing and you're just worried about not getting sued, there was recently a babysitting app that was kind of maligned by fairness researchers, and probably rightfully so, for being a complete black box and giving people no way to appeal the black box decisions. And so even if you don't care about just doing the right thing, which I do think it's the right thing to do, it's a good way to keep your company out of the media and keep yourself out of potential legal trouble. So I think I fully believe that there's a link here between decreased financial and operational risk, and like I said, I think it's a triple win, a win-win-win. So if Tom, you have any comments, that's fine, and if not, we'll go ahead and move on to the next question.
Well, I think the only thing that I would add in to that is, I think this opens the window for more, types of users and companies and industries to be able to leverage this type of methodology. Because as an example, I think a lot of times business leaders who are not necessarily as intimately involved with methodologies, data science, et cetera, there's fear in terms of understanding what's going on, what decisions are being made. They read articles like the one you described, and to me, what this does is it allows a more predictive benefit with explanation, and really starts removing some of the fear behind the unknown in these types of methodologies for those that may not necessarily be as close. So I think I agree, it is a win-win-win.
Awesome. All right. So our next question is, are there any applications in your industry where interpretability is simply unneeded? And I think I'll skip the latter part of the question, which is where do you see the greatest need? I think we've both kind of addressed that. So is there any place in your industry, or maybe any place you're even aware of, where interpretability wouldn't be needed?
I think in places where you're not making necessarily hard and fast decisions, but trying to do some form of directional triage. Like, I think fraud is a great example of that. Like if you have transactional fraud detection that's occurring. So if you go to a gas station pump and you swipe your credit card and it was just in a different location, I think machine learning models can very easily detect that. And from my perspective, I don't know if there may be some inconvenience behind having some form of check come into place for that type of transaction. But I think the explanation it doesn't matter necessarily as much, as long as it catches a few. So I think, and in those cases, it may not have denied your transaction, but it allows a better check. So those are the areas where I think that that it's not necessarily as needed. It just could provide some level of inconvenience.
Sure. So I think I was going to bring up the fraud use case also as being a place that's sort of less regulated, of course, than credit scoring, and so a place where machine learning really caught on quickly because it was bringing in more accurate answers, and it's an interesting example of trusting a model without really understanding it. I think I would, which can be okay, but I think it's something that we should be cautious about moving forward, just given now the ability to explain these models has become, sort of widely available in open source software and proprietary software. I'm going to make a bold, potentially controversial claim and say there's no need for uninterpretable models anymore, at least in the spaces that I work in. And that's simply because, machine learning models are like any kind of technology. They can be used for good or for bad. And I think it's really important if you're going to put a model out there that it comes with some instruction booklet of what it's doing and how it's doing it, in case it's used for purposes that you perhaps did not have in mind when you made it. So I'll leave it there, and I'll show one more link for a really well thought out essay that I found, or that was shared with me, for someone who worked through some of these kind of bad things that can happen with machine learning. So give me 1 second here. So Patrick M., can you release your screen share for a second, and I'll show this really quickly? Thank you.
Yes. Sorry about that.
No worries. I think it's good to show that slide, especially with me disappearing every 5 minutes or so. Okay. And like I said, this is something that we'll be sharing all these links afterwards. So this is a data scientist that works at Microsoft, and he just did a really thoughtful essay on kind of all these bad things that can happen with machine learning that I think conscientious practitioners of data science should really make themselves aware of. And of course, people are probably familiar with the Cathy O'Neil book, Weapons of Mass Destruction. This is, of course, highly related to some of those topics and brings kind of a unique perspective, and is shorter than a whole book. So you can read it, during your coffee break, something like that. Okay, so you need any rebuttal there, Tom, or you want to move on to the next question?
No rebuttal at all. Yeah, I do fully appreciate what you were saying, that there are applications where it is, interpretability is not necessarily being leveraged, but I agree with you that it should be. There's not really a driving reason to not explain now.
Cool. All right. So our last question, I believe, and this is a fun one. What types of interpretability practices are you using today? So please feel free to highlight your really cool neuro-decision technology, and anything else that you guys are up to that may be more traditional but also important for people. And then what are you excited about in the future?
So I guess the main thing that we're using is our neuro-decision technology, which we were awarded. From my understanding, one of the first, or I'm not sure if I've seen others out there, but it's one of the first AI-specific, explainable AI-specific patents, in that it takes, in this specific case, a neural network constrains the model in such a way that it creates monotonic patterns within the end nodes of that of the neural network, and it allows us to make those predictions, provide reason codes for whatever credit score was, was generated for each consumer, and then provide reasons that that consumer in the way that I described could be, receiving a higher or lower score, accordingly. And I think that from that we've extended that methodology to other methodologies that come out. And I think the thing that's been interesting and how we've had to bridge this gap is that academia and providers of software, they typically generate really strong algorithms that aren't always applicable to every use case. And in this example, we've been using regression-based procedures for over 50 years in terms of the way things have been created for credit scores. And legacy views, you always had to go back to something simple like a logistic regression, but they're still fairly powerful when you leverage segmentation in conjunction with a form of logistic model. But what this does is allows an open window into when a new methodology comes out. Can we take that methodology, apply our techniques to it that we've patented, and then leverage some of those newer capabilities that might exist, and so those things can very easily transfer into like gradient boosting, random forests, or any of the other techniques that are starting to come out and become a little more popular with pure predictive goals in mind.
Okay, awesome. And I really want to highlight for people, I think NeuroDecision is like a perfect distillation of what I mean by a constrained machine learning model. And my understanding of it, it's a monotonic neural network that can generate reason codes. And I'm personally a huge fan of monotonic gradient boosting machines for the same kind of work. And I think that we're going to see these types of constrained machine learning models play a bigger and bigger role as the importance of interpretability sort of sinks in on the market. I'm going to share my screen again really quickly to give just a brief view of what I'm excited about. And in short, my answer is I'm excited about combining all these different things that we've been talking about. So interpretable models with post hoc explanations, with fairness techniques, with just good old-fashioned exploratory data analysis and things that we've known have worked for decades. So just very quickly, I know this is a little bit convoluted, but essentially, I want people to be able to go through traditional exploratory data analysis, know thy data, do feature engineering that's explainable, and I'm sorry for the deep learning folks. I'm not sure that deep learning feature extraction is always interpretable, but some of these techniques can make it interpretable, and of course there are some versions of it that are, but these are more traditional types of feature extraction techniques. Pairing that with both traditional and newer types of interpretable models like NeuroDecision, traditional model assessment, like Tom said, people have been doing for 40 or 50 years, which I think is crucially important to understand. Machine learning is old, not new. A newer field of model debugging, essentially testing your machine learning model like it's a computer program. Some of the explanation techniques we've been talking about. And then I think two other things that I'll point out here that Tom has kind of hit on, because people have to do this in financial services, and I think it's something we should all learn from, is human review of models. So documentation of our modeling processes that's actually reviewed by humans, and then human appeal of automated model decisions. And I think this is something that data scientists need to be more aware of. If you make an app that's making decisions that affect people's lives, it's really unethical not to give them the ability to appeal those kinds of decisions. So what I'm excited about is combining all of these things that I'm showing on the screen and all the things that we've talked about. And I'm sure Tom's got some thoughts in that same direction too. It's kind of obvious, but that's what I'm excited about. So I will shut up and let Tom have a rebuttal if he needs it, and if not, we will go to audience questions.
No, I would not disagree with it with anything he said. It allows a no stones unturned type of approach with methodology, incorporating new types of information, and really, especially the benefits of like machine learning is to really has been able to explain additional value. Like when we think about the availability of data today that can be brought into various things, it allows a quick test and explanation to a feature level of the importance of new and differentiated data. So it's quite interesting when you tie it all together. So I'm really excited where we're going in this industry.
Cool. All right. Well, I see one good question already, and of course we're hoping for more because you can learn a shocking amount when you kind of turn your thinking over to the public internet. So. Give us your good questions, please, or your simple questions. We're fine with that. The one question that I'm being shown right now by the moderators is a very good question. So, given humans make decisions in an almost black boxy way and then create an explanation to justify them, what do you think the possibility of models generating their own reasonable explanations while keeping the internals of the models itself not fully interpretable? Okay. You got all that, Tom? Do you want me to read it again?
I see it as well.
Okay, great. So I'll let you give an answer, and then I'll run my mouth for a little bit.
I think it's an interesting question, and I think that that process by which we do that explanation, when we think about the black boxy type of decision making, I do believe that the human mind probably does do that, but in a sense, that explanation is oftentimes constrained because most people, I may fall on the other end of this camp, have a brain mouth filter, and I think the brain mouth filter is one that helps to create those reasonable explanations and justifications on what decisions are being made. Because if there were no ramifications, then there might be a little more chaos in the world. So I think that it's an interesting concept. But from that standpoint, the explainability of the model, whether it's business logical, may or may not matter. You can still explain it.
Sure. Okay. And I would add a couple comments here because this is a line of reasoning that's discussed a lot out there on the internet. And for better or worse, I spend time reading about it. So I think one thing that Tom and I both pointed out is these philosophical questions are interesting, but actually they hardly matter probably in financial services and healthcare and insurance, and probably sometime every kind of machine learning, it's just going to be mandated by law that you explain them. So today in financial services, education, healthcare, insurance, it doesn't matter what your philosophical thoughts are. You just have to explain them because that's what the law says. So I think that's one point that people tend to miss here. It's actually a legal thing that we explain these models. Two, I think that there's what's known as high fidelity explanations, so very accurate explanations, and then low fidelity explanations, kind of more approximate explanations. And I think there's some trade-off there, right? And that's very similar to the way human minds work. Like, you may ask me to explain my thought process, and I might give you a 5-second answer, or I could sit down and write a paper about it, and that might be more clear and accurate. So I think there's a use case for both the sort of approximate, quicker, simpler explanations, and for the more complex, high-fidelity explanations. And I think that's kind of that will be my answer to that question. I see another audience question. Can every ML model be updated to become an explainable ML? So I'll let Tom take a crack at that, and then I'll chime in.
Well, I think updating the machine learning algorithms in such a way to make them explainable is a slight adjustment to the original algorithm and the intent behind it. Yeah, I believe that most of these can be updated in a sense that and how it's done. And if any of the I guess the listeners are interested, we do have information out there available. Given that our methodology is patented, you can look at the actual nuts and bolts on how we looked into that with leveraging really a partial differential equation. So if you can apply that type of math to the algorithm at hand, then you can make updates and changes to that algorithm. But I think in essence, when you do make these types of methodologies explainable, it is a slight adjustment or change to them, and so you just have to understand what is the trade-off on making something potentially more or less explainable.
Sure. And I'd agree with that. And I'll be happy to send out some links on NeuroDecision with the kind of summary materials related to this talk, because I do think it's a really good resource for people to start wrapping their minds around. My take here is that if you start off with a fairly simple type of model, so like Tom's been talking about, multi-layer perceptron neural network, which is a fancy sounding word, but actually a fairly simple type of machine learning model. Standard gradient boosting machine, standard random forest, decision trees. I think all of these can be made interpretable. And then as I showed, there are people doing research on just straight up interpretable types of nonlinear models that are designed from the beginning to be interpretable. So to me, the lesson there is, if you want an interpretable model, start with something simpler or something constrained. And if you do have some kind of 96-layer deep neural network or other just very complex, machine learning pipeline, it may be more difficult to explain, and you may not be able to explain it. So I would caution people that I don't think any kind of machine learning can be made explainable, and because it can get too complex. And if you want to have a truly interpretable process, you need to think about that from the beginning and use more, straightforward or constrained processes. So that's my answer. Okay, so I don't see any more audience questions. Maybe we'll give it another second or two. And if not, I'll turn it over to Tom to see if he wants to make any closing statements. Okay, doesn't look like there's going to be any more questions. So Tom, any closing statements?
No, I appreciate the time today and our discussion. As always, this is it's beneficial to me, and hopefully everyone out there found some value in the discussion as well, because these are the kind of things that will continue to propel us forward.
And you'll be presenting on a somewhat similar topic at H2O World next week. Is that correct?
That is correct. Yep, and it's really an application of how we can understand taking these various elements of methodology that we have out there, including I think one of the best things that you guys have right now is the driverless AI, and I think incorporating that type of thinking, but also knowing the direction you're going and having that goal. A lot of the explainable AI, the reason for it is we have to know where we're going and what's the goal and direction, and providing the informational view into that is I'll be talking a lot about that. So thank you.
Okay. Awesome. And I'll also be at H2O World, which we'll be streaming at least parts of, maybe all of it, and we'll have that information in the follow-up material. I did see one last question come in, and I see we have 1 second or so to answer it, so I'll just try to be really quick. When does fairness input for the model kind of come in, or how does fairness come in? And that's a very complex question, actually, but we break down fairness these days into sort of things you do to the data before the model is trained, things you do to the model itself during training, and things you do to the predictions after you already trained the model. And maybe we can send some resources on that to give a better answer in the summary materials, because we're right up at the top of the hour, top of our time. We appreciate everybody staying on the line. I'm very sorry about my phone service. Somehow in the middle of Washington, D.C., my Verizon cell phone doesn't work. And we'll hope to see you maybe at H2O World or a future webinar. So thanks a lot.